Hey everybody. Okay, so usually I will have these recordings posted before Monday evening, but I'm kind of trying to learn the system on how to record this. Not using Big Blue Button because Big Blue Button deletes the recordings after 2 weeks. So I'm trying something different where I don't have to keep creating videos every semester. And also it's important to know. So some people have already gone in and turned in their lab 2, which is really great. But typically, um, or always from now on, you will have to watch the videos for this class to pass the class. One, because I give information that will only be found in the video, and then we are also sometimes going to be changing the dates. So, for an example, last semester I had a couple of students. Well, it happens every semester. There'll be a couple of students who, after the fourth week, are making terrible grades, and they can't understand why. And the reason is because they're not using the videos. So you can try to do it without the videos, but it's going to make it a lot harder for you and pretty much impossible. Okay, so this week we are starting with Lab 2, page 9 of your lab manual that is written by Shankman and Reese. For the most part, I end up saying I'm not going to read, but I end up reading through the lab manual, but you can go on and anything I skip, you can do it yourself. And I'm pretty straightforward and try to keep up with the page numbers. So, Lab 2, latitude, longitude, and time. So, total, this is 59 points, which will equal out to 100, but whenever you look, I will give you a grade out of 59 is 100, so on and so forth. So, I'll get questions about that as well. Okay, so a geographic grid is a series of intersecting lines used to locate positions on maps. Most maps are flat and use horizontal and vertical lines. Typically, the lines are identified by numbers and the intersection of lines that can be used to indicate a position. The purpose of this exercise is to 1. Become familiar with latitude and longitude, the most commonly used geographic grid system to locate positions of the Earth's surface, and then 2. To understand the relationship between time, longitude, and the Earth's rotation. Okay. So before we begin, remember to complete your plagiarism tutorial. If the link on the syllabus or in here is not working, you can literally just Google plagiarism tutorial USM and it will pop up. And then just email me the results directly and make sure you are passing. And that's all in the syllabus and on Canvas. Alright, so we've already listed this off. So geographic grid coordinate system. This is a geographic grid. It's lines that meet used to find a specific location. So here we have 0 degrees, and we are looking at latitude and longitude. So latitude measures degrees north or south of the equator. Equator is here, correct? And then there's going to be running from east to west. So think latitude is going to be lay, right? So it lays. Whereas longitude, think long legs. And these are going to measure degrees east or west of the prime meridian. Here's our prime meridian right here. And if we can zoom in, I don't think you can actually see it very clearly. But it runs through Greenwich, England, which I'll read about just in a second on page 9. So latitude and longitude is the system of imaginary intersecting north or south and east or west lines on the Earth's surface. Let me go to... Alright. Latitude is a measure of the distance or degrees north or south of the equator. To determine latitude, there are a series of east-west lines that circle the Earth known as parallels. The high latitudes are the North Pole and the South Pole, which are fixed points at the Earth's axis. Longitude is a measure of the distance or degrees east or west. Meridians are north or south lines that are used to measure longitude. The prime meridian runs through Greenwich, England, right here. All other points of longitude are measures of degrees, either east or west of the prime meridian, with a maximum of 180, located in the Pacific Ocean. Alright. Figure 2.1 illustrates the parallels and meridians on the Earth's surface. So, just showed you latitude, longitude. Here's an example of 32 degrees north, so it's always going to be latitude first. Think about that being alphabetical. LA is going to be before LO. So whenever you're writing coordinates, you're always going to have your latitude first. And you also need to put your coordinates by 32 degrees, and then we'll get into the more in-depth detail later. But it's either going to be north or south. And then for your longitude, it's either going to be east or west. All right, so first 32 degrees north, got our equator here, go up to 32 degrees right here, and then over to 65 degrees east. So we see west, correct, is going to mean west of the prime meridian, and then east. So 65 degrees east, we've got 60 degrees right here, and then we have 65 is a little bit over here, and then 32. And then you just mark that. It's pretty simple, pretty straightforward. And this is just going to be showing it closer to figure 2.1 on page 9, where instead of having a flat map, we're looking at a globe. Also, keep in mind that the equator is a little bit lower, so we're kind of looking from a northern perspective. And that also happens on page 10 when you do the question. Okay. So I'll go through this first, and then we'll kind of go back to page 10 and start doing, and I'll go over the exercises. Alright, so latitude and longitude is going to be measured in degrees, minutes, and seconds. So latitude and longitude values are commonly split 3 ways: degrees, minutes, and seconds. Each degree has 60 minutes. Each minute has 60 seconds. And that's it. Alright, so degrees here. How many, imagine, I don't think I can type, or I can type on here. Think of this for a second as hour. Obviously, it's still degree. But you can also think of it as in time, as in how many minutes are in an hour, 60. And then how many seconds are in a minute, 60. So just like that, each degree has 60 minutes. Each minute has 60 seconds. Alright, and these are units of latitude and longitude. So if you were measuring something kind of far off, like we were just looking for a town, we could do that using only degrees. But if we were trying to get into more detail to find where in that city or town it was, we would use minutes. And if we were looking for an exact location, we would also include seconds. So you could look on your iPhone right now and know that there is going to be degrees, minutes, and seconds, because it's noting exactly where your location is. Okay, guys, sorry about that. I was kind of learning how to do this quick player. So I was actually able to pull up the lab manual. So we've already gone over this, but then we're just going to kind of go through, and I'm going to show you how to do each of these so you're not lost. And like I said, this is pretty easy on this first one. I don't know if I can draw on this, but for example, it says number 1, plot and number the following coordinates. Latitude is 44 degrees north and longitude is 65 degrees west, and I'm not able to draw on this. No, I cannot. So I will just kind of, you can follow my arrow, but start with latitude, 44 degrees north. We've got 40 right here, 60s right here, so halfway would be 50, so you can go a little bit lower than that. And then we have longitude is going to be 65 degrees west. So we can see that there's 60 degrees west, 40 degrees north. We're staying on 44. Go over and a little bit past this. So you would put a dot right here where my arrow is, or it's this longitude or a coordinate, and you can just label it with A. So make sure you label it, and then you'll do the same thing for B, 12 degrees south. Go to 0 degrees right here. Go down. We've got 20 down here, which is a little bit cut off the page. Or actually, I can just move down. 12 degrees, half of that's 10, so about 12 will be right here. And then your longitude is 4 degrees east. So you see our prime meridian over here. And this is 30, half would be 15. So you can kind of measure it out. It doesn't have to be perfect, but it's going to be pretty close to over here. And just make a dot and then put B. Alright, and then you're going to sketch and label the following parallels. So you've got A, the Arctic Circle. Arctic Circle, I'll tell you, it's going to be 66.5 degrees north for the Arctic Circle. And even though it doesn't ask you to label it, the Antarctic Circle is going to be the opposite. So it'll be 66.5 degrees south, which we'll learn about later on in the semester. And then your tropics are going to be Tropic of Cancer and Tropic of Capricorn. So next to it, go ahead and write, like you wrote 66.5 degrees north here. Right next to Tropic of Cancer, 23.5 degrees north. And then Tropic of Capricorn is 23.5 degrees south. And then you'll go and you will label these on here. So something you do not do that people have done in this class is, oh, I don't think I can underline or strike through even on this. Nope. Okay, won't worry about that. Is they will go straight across. They will take a ruler, they'll go to 66.5 degrees right here, and then they'll put a line straight across. That is not how it's going, because our lines right here, correct, are latitudinal lines are not going straight across, correct? And our longitude is not going straight down. It's moving with the globe. So when you do your 66.5 degrees for your Arctic Circle, you're going to go up here to 66.5 and then follow around this line, and like you're drawing on an orange. And some people do dotted lines, some people do colored lines. I'm okay with it. And then over here, you can just label tropic or Arctic Circle. And then do the same thing with the Tropic of Cancer. We've got 20 degrees north right here, so a little bit above that, because this is going to be about 30 degrees right here. 23.5 is probably going to be right here. Make a line that goes all the way through here. And then you can label over here 23.5 degrees north, or you can say Tropic of Cancer. Or you can put B if you'd like. But put 2B, because we've already got a B for 1. But I would know the difference. Tropic of Capricorn's 23.5. So there's 20 degrees south. Like I said, it's going to be a little bit up under here. Alright? Okay, so once you've done that, it says the Earth is often depicted on flat maps because they're easier to work with than globes, such as this one right here. The surface of a sphere, however, cannot be flattened without some distortion of the surface features shown. The Mercator projection is one of the most common maps on Earth. Note on this map that the meridians are parallel. Actually, meridians are farthest apart at the equator and converge at the poles. Therefore, this map projection causes distortion, particularly at the high latitudes. Still, you can easily use the grid coordinations to see this. And we'll kind of learn about that. But what it's saying is, obviously, on a globe, you're going to notice that your longitudinal lines are going to be getting closer together, right? Kind of like a pizza, a weird thin pizza, but pizza. And we won't have to focus that on it until later in the semester, but that's what it's saying. All right, so on number 1, it says find your position at the Mercator projection, which is figure 2.3, and determine the geographic grid coordinates. So go to page 12 for your Mercator projection map, and it wants you to label Hattiesburg, Mississippi. And mine is sideways, and I can't change it without closing. Nope, I can. Okay. So what you'll do is you will use the coordinates given, which the coordinates of Hattiesburg, Mississippi is what it's asking for. So the coordinates for Hattiesburg, Mississippi are 31 degrees, 20 minutes north, and then the longitude is 89 degrees and 18 minutes west. If you have something a little bit different, it's okay. If you put 31 degrees north and 89 degrees west, that's okay, because it's not going to matter because we are looking so far off. So you're going to use those coordinates though. And to do that, I like to go ahead and with my class, I tell them to put a little arrow right here so you remember that that's your equator. These little dotted lines right here are going to be the tropics. So we've got our Tropic of Cancer here, our Tropic of Capricorn down here. And so we are going to plot the coordinate for Hattiesburg, Mississippi, which is 31 degrees north. So we've got 30, and you can already put north right here and south right here. So anything south of the equator is going to be south. Anything north of the equator is going to be north, obviously. Whereas you can also, if you want to, circle right here. That's going to be our prime meridian. And then put west over here. And then put east over here. That helps students sometimes. Okay, so 31 degrees north. It's going to be 31 degrees is right here. And then our longitude is 89 degrees west. So here's 90. But we can kind of already guess of where Hattiesburg, Mississippi is. And so we know it's going to be about right here. So just make a little dot on there. And then you can write Hburg on there, on that map. But it does need to be listed. And I will figure out next week how to actually edit on this PDF while recording, if I can. But just follow my arrow. So put a dot right there and then put Hburg. Or if you have good enough handwriting, you can write out Hattiesburg. Okay, and then for the next part, we're looking at page 11. It says, the following positions will be given by the lab instructor. Locate and plot each position on the Mercator projection. Alright, so this can be found in your PowerPoint. So, page 11, write in these coordinates, just fill out this, and then next to it, write the place names. You've got A, B, C, D, E, so you don't have to write out the complete location names. You can just write it, coordinate it on A, B, C, D, E. So for example, you'll go to, we'll have it filled out, correct? And then you will go here. Let me look. First coordinate, 22.3 degrees north, which is basically 22 degrees. And then, well, it's not going to be exact. It's not going to be 3 minutes, but it would be like a third of 60. But since, like I said, since we're so far off, you can really just stick with the minutes. So it's 22 degrees north. There's 15. It's going to be, remember, our Tropic of Cancer is 23.5. So it's going to be a little bit under that. And then our coordinates is also going to be 102 west. So this is west, right? We've got 0. West is over here. So 102. We've got 90. It also helps to split these in half. So these are 30 degrees separated, correct? So half of that would be 15 degrees. So 90 plus 15 is 105. So it's going to be a little bit to the right of 105. So you'll go down to 22.5. So be about right here. Also, all these coordinates, obviously, these cities aren't out in the middle of the city. So if you're checking yourself, you'll know kind of basically, it's like, okay, it's not going to be over here because that would be out in the middle of the ocean. So let me just check. It would be about right here. And I'm not getting very specific, but I just want to make sure you have an understanding of this. So you'll do that with each of these. So when you get done with page 12, you need to make sure that you have, it's 12 points total. You'll have 6 locations total because you've got the 5 here, A, B, C, D, E, and you can just make sure that they are labeled. You can label out using the whole title of the place, or it's easier just to say A, B, C, D, E. Have those, and then you need to have Hattiesburg, Mississippi. So 6 locations plotted. Make sure you have them plotted, and make sure you have their names. Pretty simple. All right. Let's go back here. Page 11. We've completed this. Skip number 3. You can just cross through it. And then on page number 4, we're going to be learning about antipodes. So before we go any further, I'm going to jump back into the PowerPoint. And we're going to talk about antipodes. So antipodes are opposite points on a globe. So they're diametrically opposite, a point opposite on the Earth's sphere, also known as an antipode. It's a line from one point to a diametrically opposite point that will pass through the center of the Earth. So an example I give a class is, if I had, when I used to teach in-class lectures, it was easier because we had a globe. But imagine that I have a globe, and I have a long metal rod, and I was able to stick that rod in at one point of the globe, and then go straight through the globe. The antipode is where that rod came out the other end. So if I stuck it in at 90 degrees north at the North Pole, and went straight down, it's going to obviously come out at the South Pole. So the antipode to the North Pole is the South Pole. If I stick the rod in at 60 degrees north, right here, and that is, let's say I went over and I had it on the prime meridian, then it would go through over here and come out. Imagine that it came out over here, right? If that helps. Or you could imagine that I have a long rod and I stuck it through an orange. The antipode would be the place where the rod came out of the orange. Okay, so here's how to find an antipode. Alright, so you just have if you just have degree measurements, meaning you only have 180 degrees versus 180 degrees and 32 minutes, you're going to do this. And you'll always do these first two steps. So, you're going to first reverse your latitude sign. And I kind of combine this two steps into one step. But you'll reverse your signs, your latitude and longitudinal signs. So, if it's north, like here, we're going to change north to south. And then the longitude is going to be changed from west to east. Makes sense? North to south, west to east. If it was opposite, this had said 18 degrees south, we'd have changed it to north. And same thing with here. If it had been east, we'd have changed it to west. Alright, so we can see that here already. Okay, and the second thing you do is you subtract your longitude from 180 degrees. So remember, latitude is always first. Correct? Because LA is before LO. So you're going to take 50 degrees. Here's our example right here, 18 degrees north, and the longitude is 50 degrees west. And you will take 180, and then you will subtract 50 degrees, which is going to be 130 degrees east. In the past, I've had students who, for some reason, get a little bit confused about this. But you're just finding the difference. All right, so you're taking your largest number, which is 180 degrees, or you're just always going to take, I don't know why it's, no judgments, but it shouldn't be that confusing of that. You're just taking your longitude and subtracting it from 180. Alright, so it's 130 degrees east. So, if you were to stick a rod through the globe at 18 degrees north and longitude is 50 degrees west, then it would go through, always it's going to show up at 18 degrees south. It's a lot easier if you can find a globe and think about that. If you go in at 18 degrees north, which is going to be about right here, it's kind of a little bit less easy to see when it's not so dramatic, but if you came in at the northern part, you would come out on the other side at 18 degrees south. That's pretty easy, but you're not going to have the same longitudinal coordinate. It's going to be at the other end, and all you have to do to find that is subtract it from 180, so it'll come out at 130 degrees east. Alright, so that's pretty easy. Now, if you have minutes, for instance, you have 18 degrees, 20 minutes north, and then your longitudinal coordinates are 50 degrees and 40 minutes west. What you're going to do is, if you're good at math, this makes sense. You're doing the same thing, except you have to convert your 180 degrees to where it has minutes in it. So you're going to change 180 minutes equals 179, or 100 and, I'm sorry, let me start over. 180 minutes equals 179, 180 degrees equals 179 degrees and 60 minutes, because there are 60 minutes in a degree. So this 179 degrees and 60 minutes equals 180 degrees. Does that make sense? You're doing the same thing. It was just that you made it where you could easily subtract from it. Okay, so you're doing the same thing. First thing you're doing is you're reversing your latitude and longitudinal signs. So north becomes south, south becomes north, east becomes west, west becomes east. Always do that first. When you first see something, go ahead, scratch this out, change it to south. I just write it above it, or you can just go ahead and write it to the side, which you'll see in a second. And then you'll change your east or your west to east, which they've already done that here for us. And then your latitude's going to stay the same, correct? Latitude stays the same. Fill that out. And then for your longitude, you're going to take 179 degrees and 60 minutes, and then you're going to subtract the minutes given, or the degrees and minutes given to you, which is going to be 50 degrees and 40 minutes. So, make a line right there. You're not having to go all the way over. 60 minus 40 equals 20. So that's 20 minutes. And then degrees is 179 minus 50 is 129 degrees. So you will write your antipode for your 18 degrees, 20 minutes north, and 50 degrees, 40 minutes west is going to be 18 degrees, 20 minutes south, and 129 degrees and 20 minutes east. Okay, so I'm going to do We'll do D on page 11, just to make sure. Okay, so D on page 11, I can't fill this out because I don't know how to write yet on this. But let's go. It's going to be in here. Alright. Your latitude for D is going to be given to you. It is Hattiesburg, Mississippi. So it's going to be 31 degrees, 20 minutes north, with a longitude of 89 degrees, 18 minutes west. That's Hattiesburg, Mississippi. So on D on page 11, number 4, write this in. Okay, so first thing you're going to do is you're going to take that north, you're going to change it to a south, and then you're going to take this west, change it to an east. Your latitude's going to stay the same, and then you are going to take 179 degrees and 60 minutes, and you're going to subtract from that 89 degrees and 18 minutes west. So your latitude is going to stay the same, except it's going to turn into a south, and your longitude is going to turn to an east, but then you subtract 179 degrees and 60 minutes by, you subtract it by 89 degrees and 18 minutes west, or 18 minutes. And your answer for that, or your latitude is going to be, your latitude is going to be the same, but your longitude is going to be 90 degrees, 42 minutes. Sorry, it's kind of like a tongue twister. Okay. So we're skipping that. Do all of these. Pretty easy. If you have any questions, feel free to write it in the comments section. Remember, on page 12, you have 6 locations that need to be plotted and labeled. Alright. And now we will go to latitude and longitude distance. Okay, so I'm going to quickly read over through this, and then I'll explain it. Alright, so the length of 1 degree of latitude on the Earth's surface is approximately 111 kilometers. So the length of 1 degree of latitude on the Earth's surface is approximately 111 kilometers. So it means for each degree that we look at, let me move back up here, we've got degrees correct. For every degree, like between 20 degrees north and 21 degrees north, it's going to be approximately 111 kilometers. And that's always going to be consistent. If you went in every degree, the distance in those degrees is 111, and it would stay consistent, right? Makes sense because nothing's changing here. Everything's staying the same. But if you look and see, let me get back here. Okay, so this varies only slightly with distance from the equator because the Earth is not a perfect sphere. In contrast, the circumference of parallels and the 1 degree of longitude decreases as you move from the equator because your longitude is getting closer together, right? So you're not going to have the same distance from a degree here as you would here. Just like you're not going to have the same distance between 30 degrees and 0 degrees, or for every 30 degrees. It's going to be, the distance is going to get smaller as you go up, correct? Or if you go below the equator. But as you move closer to the poles, it's going to get smaller. So let me get back to, okay. Decreases as you move from the equator to the North Pole or South Pole. Longitudinal distance can easily be calculated for any latitude. The circumference of the Earth, C, at any given latitude parallel decreases in direct proportion to the cosine of the angle latitude. The circumference of a parallel of latitude can be calculated as follows. So C, as it says up here, is going to be the circumference of the Earth, equals 2 pi, and I know pi goes on infinitely, but pi here is going to be 3.14. So go ahead and write next to it 2 times 3.14, and it's going to be times r, which will be, where does it say it? Is the Earth's equilateral radius, which equals 6,376 kilometers, or if you're doing miles, 3,960 miles. and X is going to be your latitude. So you've already got a lot of that, so you can go ahead and put in. Next, you can put it here, or you can just write it here. C equals 2 times 3.14 times, and we are doing, let me make sure what we're doing on the next page. We're going to be using, I think we use kilometers. I've got multiple labs put into one, so let me check. And remember, that's going to be important. Yes, we're using kilometers. So on the next page, when we do this, you have to list that you're using kilometers. So we are using kilometers. So 2 times 3.14 times 6,378 times the cosine of x, which is going to be the latitude, which we'll have later. So what you need to do is you will fill out 2 times pi times 6,378. And you can give me the answer for that, which is going to be 6,378 kilometers. And so once you have that, it's a little bit easier. I wish I could write this down so you could see what I'm saying. But you don't have to continuously do that problem. All right. So remember, this formula is not entirely correct because the Earth is not a perfect sphere. The Earth bulges at the equator, and therefore the equilateral diameter is slightly greater than the polar diameter. However, the formula is accurate to within 1%, so we're pretty close. And since we're doing this for an intro level class, it's okay. All right. So on the next page, after reading all that, you're going to go to page 14, and we're going to give you the latitude. Let me find out where that is on the PowerPoint. Okay, so again, 2 times pi times r. Radius of the Earth is 6,378 kilometers, and x is the latitude. And then there is a cosine button on your calculator. So, of course, there's one if you're using Texas Instrument. It's pretty easy to find. Now, if you don't have a Texas Instrument calculator, you can use your iPhone. You'll have to turn your iPhone long ways or sideways so it'll show it, and you'll see degrees. It can either be degrees or radius. And I'm going to have to go grab my phone to make sure that I remember which way it goes. Because if you use it in the wrong way, it will not, you can't use radians. You have to use degrees. So before calculating the circumference, make sure your calculator is set to degrees on your phone. And you can easily find this out with testing your iPhone. You got my phone. Oh yeah, thank you. Okay. So let me just make sure how to do this. So I'm looking at my iPhone. If you look up in the top left corner, you'll see RAD. If you click at the bottom, you have DEG at the very bottom corner, and that'll change it out. So, and it also depends. I have had people in the past who use Androids, and it's like the opposite. So just make sure you're testing this when you go in. All right, so for page 14, go ahead on your first column under latitude, you're going to put 69 degrees, 33 degrees, 50 degrees, and 22 degrees. Alright, so let me see which one I want to use in as an example, because I want to give you an example, and I guess I can just stick with the one on the PowerPoint, because that would probably help you. But I kind of want to do one that's in the book, but I guess we'll stick with this. Okay, so your example that they give in the PowerPoint, 66 degrees. Alright, so we've already done the first part by multiplying 2 times 3.14 times r times your cosine. The easiest thing to do when I say doing this is go ahead and get your cosines ready. So you'll do the cosine of 69 degrees. So there is, you'll put in 69 first and then hit cosine. And I have to figure out, and I had mine in radians, which I could easily see. So it is So it shouldn't show RAD. It should say RAD down there, and that means it's in degrees. 69 cosine. Okay, so you won't see RAD at the top. You will see RAD at the bottom, and that means it's in degrees. So I like to, on my page 14, I wrote cosine to the left, so you'll just go ahead and get your cosine of each of these latitudinal coordinates. So the cosine of 69 is 36, or 0.36. It's 0.35836, but we can just round over. So it's 0.36. Cosine of 33 is, you put in your iPhone, clear it, put 33 cosine, and that's 0.84. 0.838, but we're going to round it over. Clear it, let's see, 50 cosine. It's going to be 0.64. And then 22 cosine is 0.93. So I like to write those over here. That way it's very, very easy because you'll already have this done. So let's just do this since I've just pretty much did it. I like to do this instead. That way you kind of have an idea of how to do this. Alright, so for this one, you're trying to find your parallel circumference. Parallel circumference is going to be C. So I like to write a C right here. So that way, to find that, you are just going to do 2 times 3.14 times 6,378, which is going to be, let me find what that number was in my notes. It is going to be, I literally just said it, but my notes are everywhere. (6,378 kilometers) times, and you already know the cosine of 69 because it is 0.36. So your parallel circumference for 69 degrees is going to be 14,419.38 kilometers. And make sure you put kilometers. And I just want to try that out really quick, just because I like to make sure it's right. Alright, so 6,378 times that's not right. Let me check what I'm doing wrong. Okay, 0.36 times what am I doing wrong? Let me try it long ways. 2 times 3.14 and I'm proof that people who are terrible at math can do this class. .28 times radius, which is, oh, because I'm using radius, it's not the same thing. Okay, times radius equals 6,378 equals 40,053. So I've been saying it's 6,378. It's not. It's going to be 40,053.84. Let me write that in my notes. And then times 0.36 equals. Okay, that's how we get it. So I've been saying that 2 times 3.14 times radius, which is 6,378, equals 6,378. And I'm a little tired because I've been doing schoolwork. It's going to equal 40,053.84 kilometers. So 40,053.84 times your cosine, which is 0.36, is going to be 14,419.38 kilometers. All right, so you'll have that right here. All right, after that, once you have your circumference, to find your longitude, you're going to, and they've given you it here, you're going to multiply your longitude or your circumference by 360. So you'll take 14,419.38, and you're going to divide that by 360, which is 40.05 kilometers. Or just put, you don't even have to put kilometers there. But make sure you have it on your parallel circumference. Okay, sorry that took me a second. Haven't done this in a couple of months. And again, I've pulled multiple lab manuals together to do this. So it is 40,053.84 is your 2 times pi times radius, which is 6,378 kilometers. And then you're just taking that and you're multiplying it by each cosine. So you'll take 40,053.84 and then multiply it by 0.84, which is your cosine for 33 degrees latitude. Okay. You'll do that for each of those. You will skip. Let's see if we're skipping. What we're skipping. 14. We've got page 15. Okay. I want to make sure we're not skipping anything that we need to. Alright, let's go back to your lab manual. Next week will be a little bit easier, especially if I can figure out how to draw on this. Okay, so determining distance by coordinates. So distance between points within a small region, a few degrees latitude and longitude, can be easily calculated even if the points are not on the same parallel or meridian. The calculation uses the Pythagorean theorem that states in a right triangle, and you probably remember this from college algebra, c squared equals a squared plus b squared, where c is the distance between the points, the hypotenuse, and a and b are the adjacent sides of the triangle that follow a meridian in parallel, as shown in figure 5.2. Alright, so to convenient find the distance between 2 points, we can restate the simple formula so that c equals the square of x squared, or the, hold on a second, my computer's, okay, so to conveniently find the distance between 2 points, we can restate the simple formula, here we go, where x is the latitudinal distance and y is the longitudinal distance. Alright, so let me look, we'll go down, or you can just keep it c squared equals a squared plus b squared. Okay. 14. I'm on page 15 now. Okay, so remember that 1 degree of latitude is constant at 111 kilometers. Go ahead and highlight that or underline it. However, remember we must determine the distance of 1 degree of longitude for the given latitude as shown on page 14. Because remember, it's going to vary because it's not consistent because it gets closer as it goes to the poles. Alright, so we have to I give you the coordinates for problem 1 and problem 2. You can find these in the PowerPoint. Alright, see this here? I kind of skip around a little bit. Alright, so for problem 1, you've got the latitude, which is 111. Your longitude, though, and you can just write this next to it, is going to be 111 kilometers. Alright, so just put this in on point A and point B. It says point E and point F. It's going to be point A and point B. Alright, so first is going to be 12 degrees north and 32 degrees east. And then 8 degrees north, 30 degrees east. Alright, so what you do is you find your distance in between your latitude and your longitude. Alright, so for instance, and by that I mean, you take this, they've got it right here, but I just subtract here. So you can just take 12 minus 8 and right under that 4. And then your difference in your longitudinal coordinates is going to be 2 degrees, correct? It's because you just take 32 minus 30 and you can write it there. So we've got that. So we've got 4 right here, 2 right here. Then you're going to take those and you're going to multiply them by the distance, by your constant distance or your distance in degrees. So 4 times 111 equals 444, and make sure you put kilometers. Longitude is going to vary, but I told you it's 109 degrees for the degree of longitude. So you're going to say 2, because that's your difference in your longitudinal coordinates. 2 times 109 equals 218 kilometers. Then you're going to take those and you're going to plug them into your Pythagorean theorem. So you're going to say c squared equals 444 squared plus 218 squared equals the square root of the answer. So let's just go ahead and do this together. And remember, for all these, you're going to have 4 times, or for the next one, you're going to have the same answer because the difference is 4. So 4 times 111 is 444 kilometers. 2 times 109, 218 kilometers. I'm already saying that, 444. Let me turn my things, all right, or 444 times 444. But I'm trying to make sure you can do this on your iPhone calculator, which you can. 444, you'll see x squared, you hit that, and it tells you 197,136 plus 218 squared, which is 47,524. And then that's going to equal 244,660, and then square root that. And you can do that by, let's see, the square root, you have it. It's easy on a Texas Instrument, but you'll see the 2 with a square root, and then it's x. And then you just do that, and then 244,660 equals, and it works, and it's 494.63117, but you're going to round it. So, pretty easy. You can do this all on your iPhone. Alright, so you do the same thing. Take 12 minus 8, 4 degrees. 32 minus 30. Oh no, we're looking at the wrong one. That's problem 1. We just did. Problem 2. It's going to be 20 minus 16, which is 4 degrees. 53 minus 50 is 3 degrees. 4 times 111 is 444. 3 times, and our distance between degree of longitude is 104. Whereas the last time we used 109. So you take 3 times 104. And then you're going to square root that. So your answer for latitudinal distance between points X is going to be right in there, 444 kilometers. And then your longitudinal distance between points, or your points, it'll basically be on this D, or you could say Y, or keep it Y. It is going to be 3 times 104, which is 312 kilometers. Make sure you write kilometers. And then to find the distance between these points, you're going to plug them into the Pythagorean theorem. C squared equals 444 squared plus 312 squared. Add those, find the answers for each of those, add them together, and then square root that answer. And then you're going to get C equals, and it'll be, I don't want to give you that, it'll be 542.66 kilometers. I would rather just explain it to you and make sure you have it right. But go through that. You'll skip problem 3. So you'll do problem 1, problem 2, skip problem 3. You're skipping, you read page 16, but we're skipping it. 16, 17, we're not doing 17, 18, alright, page 18, skip all this. Time. Alright, the time of day is determined by the position of a meridian relative to the sun. It is noon on the meridian facing the sun and midnight on the diametrically opposite meridian. The Earth rotates 360 degrees per day, or 15 degrees per hour. The Earth rotates west to east, and therefore positions to east are always later, and the positions to the west are always earlier. Alright, so the further you move east, the later in the day, you're going to add an hour, correct? Which I'll say in a second. And if you move west, you're going to be earlier. This is the reason why. Because the Earth rotates, the noon meridian and the time at all meridians is constantly changing. Most of our time keeping uses standard time zones that are approximately 15 degrees of longitude wide. All areas within a time zone have the same time of day, which eliminates the needs of constantly changing times as you move east or west if you remain in the same time zone. There are 24 time zones, each 15 degrees of longitude and representing 1 hour of the day. Adjacent time zones differ by 1 hour. The time zone immediately to the east is 1 hour later and to the west is 1 hour earlier. The time zones are centered on the central or standard meridians of the zones, which are 15-degree intervals beginning with the prime meridians 0, 15, 30, 45, so on and so forth, all the way to 180. The boundaries of the time zones extend 7.5 degrees on either side of the central meridian, and the exact boundaries of the time zones, however, are irregular so that they coincide with political boundaries. So what all this just said was, let me turn this. We've got time zone here. Now, before we do anything, this manual has not been updated, and it was wrong from the get-go, and we're working on fixing it sometime either this summer or in the fall. But go ahead and mark that your prime meridian is right here. See, 0 degrees. What I said was every time you go right, you're going to be adding a time. This is backwards. So this needs to be -12, -11, -10, so on and so forth. That needs to be a -1, where everything to the right of the prime meridian needs to be a plus. So go ahead and do that. Just go plus, 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 plus. I don't ever use the bottom. Nobody ever uses it. It says it's best to use the top. It's a little bit easier. But if you want to go ahead and change them, I did in my lab manual. But you're pretty much going to stay using the top. So change all these to negatives. Make a little mark right here that says your prime meridian, or just has 0 right there, so you can keep in mind where that prime meridian is. Alright. And then I like to put a west over here and an east over here. And you can put a negative over here and a plus right here. Kind of keeps everything in order. Alright, now what it's saying is, let me go back and kind of look. Pretty much it just breaks everything down. It's saying, you see 0 right here. This is 15 degrees. That's the next zone. It's the middle of the next time zone, right? 15 degrees. And then over is 30 degrees. Alright, so that means that this would be 45 because you just added on 15. And then in between that, it's saying, let's see, 7 point, where did it say it? Okay. Intervals again, the prime zone 0, 15, 30, 45. The boundaries of the time zones extend 7.5 degrees on either side of the central meridian, meaning each side over is 7.5. So this is 60, this is going to be 67.5 degrees west, right? That's going to be 97.5 degrees, 0.5 west. This right here is 7.5 degrees west. So it's broken down into where it's 15 degrees each one. And then on each side of these meridian intervals, or meridian centrals, it's going to be 7.5 degrees each way. And this is our prime meridian. So when I say meridian, there's a difference between meridian and prime meridian. Alright, so you should pretty much learn this in class, but I like to go over and do some of page 20 with people so it actually applies it and makes sense. Alright. Skip on page 20, skip 1, 2, and 3. And then on 4 it says if the time is, and we're going to use 1 p.m. in your time zone, what is the time or standard time at the following meridians? Alright, so if the time is 1 p.m. in your time zone, and when it says your time zone, it is saying Hattiesburg, Mississippi. So does anybody know offhand what time zone we're in? We're going to be in the -6 time zone. Alright. So we are in -6. It's right here. Alright, and I just always tell my students to just write -6 right here so they know their time zone. Alright. So what you're going to do is, if the time is 1 p.m. here in -6 time zone, what is it going to be at the following meridians? Alright, the first one is 0 degrees. We see 0 degrees right here. So it's 1 p.m. right here. Remember, when we move right, we are adding an hour. So if you go to Atlanta, which is in time zone -5, they are going to be an hour ahead of us. So 1 p.m. right here, 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m. So on page 20, the first one, you're going to write 7 o'clock p.m. You have to write p.m. or a.m. Next one is 10 degrees east. So 10 degrees east isn't over here. It's going to be over here. Remember, this is 7.5 degrees, so we know it's going to be in time zone 1. Yeah, this is 1. Okay, so we are looking to get right here. So if it's 1 o'clock in our time zone, we're trying to figure out what it's over here. So we start over here, 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 8 p.m. And I'm kind of taking the long way just so you understand where I'm coming from. Let's go to the bottom. And I have to give you these. These are going to be on the PowerPoint. This goes over it. It's pretty much the same thing. Everything I just read, this kind of gets into it, but it's not very helpful. I feel like I can just explain it better. Yeah, make sure to change your pluses to minuses. Stay at the top so it's easier. And then we've got 0 degrees and 10 degrees already given to you, but at the bottom, write all these in. But we're going to do 32 degrees east, because I always feel like the last one's kind of like a trick one. So 32 degrees east. I don't think it is. Let's pick one that's to the west. Hold on 1 second. Let's do 74 degrees west. Right here. Alright. So we have to find 74 degrees west. Actually, I want to find one. Let's do 149 degrees. No. 118. Let's do 118 degrees west, because I just want to show you what it's like going backwards. Okay, so it's saying if it's 1 o'clock in our time zone at -6 time zone, what is it at 118 degrees west? So we're west. 118 obviously is going to be, it's 2 degrees off of 120, so it is in the -8 time zone. So we're here. So since we're going back, it's 1 o'clock p.m., it's going to be noon, and then it's going to be 11 a.m. So for 118 degrees west, it's going to be 11 a.m. because we are going backwards. We started here, and it's 1 p.m. where we're at in Hattiesburg, Mississippi. We're trying to figure out what it is for this time zone right here, which is 118, which is the -8 time zone. So we just go backwards. All right. So 1 p.m., noon, 11 a.m. All right. Number 5. We're basically doing the same thing but going backwards. It says if it is noon, 12 o'clock p.m. at the following meridians, what is your time? What is the time in your time zone? So the first one they give you is going to the prime meridian. All right, so we're still figuring out it's noon at the following meridians. What is it in our time zone? So it is 12 o'clock right here in Greenwich, England. 12 o'clock. We're going to go back. And as we go back, because every time you go to the left, you're decreasing your time, you're going to say 12 o'clock, 11, 10, 9, 8, 7, 6. So it's going to be 6 o'clock in the morning. All right, made sense? Now let's do 52 degrees west. 52 degrees west, it's going to be 60. 52 degrees west is still going to be in +4. Right, because 60 minus 7.5. And we're doing 52. Let me make sure I got that right. I'm terrible. Okay. So, 52 degrees west. And honestly, people will say like 9 a.m. or 10 a.m. and I never counted off that big of a deal. Alright, so, because it's going to be right on the line. Alright, so, but I'm going to say it's in -4 time zone. Alright, so it is 12 o'clock. We're going 2 over. It's going to be 11 o'clock a.m., 10 o'clock a.m. Alright. And then let's do 170 degrees west. Alright, so which is going to be right here. There's 180. Let me find mine. $180's right here. -11. 180. Okay. And it's going to be noon. 1, 2, 3, 4, 5. Alright, so we're starting here. Noon, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock p.m. Alright, and that's it. You're just going and working. You're doing everything backwards on the second one. And let's see. That is the end on page 22. You are skipping that. You're skipping page 21. And you are done. I'm really sorry that this was kind of all over the place. But it will hopefully be better next week. So I'm going to just go through quickly. Answer all of these. Make sure that you plot. You should have 6 plot points on this globe, and they need to be labeled. Well, you'll have 3 plot points, and then you'll have 3 lines. Remember, Arctic Circle, have it going parallel with your lines. And then Tropics, go up to 23.5. Follow around. Do not go straight across. And then 23.5, it's going to be right up under that 20 degrees south. Your coordinates are given to you in the PowerPoint. Coordinates given here in the PowerPoint. Skip 3. Answer these. This is going to be in the PowerPoint. It's Hattiesburg, Mississippi's coordinates with the minutes. So you got degrees and minutes. On page 12, you need to have 6 points labeled. That includes Hattiesburg, Mississippi. You're not doing anything on this page. It just gives you 2 times pi times r, which is 6,378 kilometers. So make sure you put kilometers on the next page. Really sorry for getting stuck on thinking that this whole answer was 6,378. And then your latitude is given to you in the PowerPoint. Go ahead, and it's easier if you just answer your cosine. If you don't, it's fine. But your cosine, you can just have it right here. That way you can type it in easily. Your circumference C that's given here, that is your parallel circumference. So right, C equals. And then all you have to do is take this and then divide it by 360 to get your degree of longitude. Pythagorean theorem, you don't have to use this. It's the same thing. It's just easier just to have them together. Or it's basically what I showed you. It's just kind of broken down. Problem 1, problem 2, these are in the answers for these, or all this is in the PowerPoint slide. Problem 3, we're skipping. Skip this. Skip this. And then your time. You're just going to go on this page, and then you're going to answer, skip 1, 2, 3, and then answer 4 and 5 of this page. All right. If you have any questions, make sure to go into the discussion board, and I will get back to you as soon as possible. This is due at 5 p.m. Make sure that you are turning everything in by 5 p.m. on Friday, okay? And have a great evening.